Today let us look at the fundamental theorem of arithmetic. We have done prime factorizations of numbers, and we know that any composite number can be expressed as a product of prime numbers. Recall that a composite number is a positive integer which has at least one positive divisor other than itself. In short, a composite number is not prime. Now we already know this from prime factorization. So expressing a composite number as a product of prime numbers is known as the fundamental theorem of arithmetic. Now this theorem is applied in finding properties of numbers. We shall simply prime factorize and observe. Let us look at a few problems. Explain why 7 times 11 times 13 plus 13 is a composite number. Now from the fundamental theorem of arithmetic, we know that a composite number can be expressed as a product of prime numbers. But here we also have an addition sign. So let us look at the given composite number. We could take 13 common. Let us solve the bracket and prime factorize 78. Now we could express this as a product of prime numbers. 2 times 3 times 13 square. Now on the left hand side we have the given composite number, and on the right hand side we have a product of prime numbers. So by the fundamental theorem of arithmetic, the given number is a composite number, or 7 times 11 times 13 plus 13 is a composite number. Let us look at another problem. Check whether 6 to the power n can end with the digit 0 for any natural number n. We are looking at digit 0. Now the simplest number that has digit 0 at the end is 10. So if 6 to the power n ends in the digit 0, then it should be divisible by 10. Let us prime factorize both 6 as well as 10. We see that 6 has the prime factors 2 and 3, and 10 has the prime factors 2 and 5. Now for any value of n, 6 to the power n shall have the prime factors 2 and 3. These prime factors won't change. Let us also check what happens to 6 to the power n for different values of n. We see that 6 to the power 1 ends with 6. 6 square ends with 6 as well. 6 cube ends in 6. In fact, it seems that for any value of n, 6 to the power n is going to end in 6. But this is observation. How do we prove this for all values of n? We look at the factors that are uncommon between 6 and 10. We see that the factor 2 is common between 10 and 6. Whereas the factor 5 is not common between 10 and 6. Now since 5 is not a prime factor of 6, 6 to the power n cannot end with the digit 0. Look at this simply. Only 2 times 5 could give us a 10 or a digit 0 in the end. Now since 6 to the power n does not have a 10 or 2 times 5, it cannot end with the digit 0 or any value of n. Let us look at another problem. Show that there is no value of n for which 2 to the power n times 5 to the power n ends in 5. Now 2 to the power n times 5 to the power n, we could simplify and write this as 2 times 5 whole raised to the power n, or 10 raised to the power n. Now let us see what happens to 10 raised to the power n for different values of n. Logically, we can see that such a number has to end with 0. So for any value of n, 10 raised to the power n would end with 0. So there is no value of n for which 10 raised to the power n or 2 raised to the power n times 5 raised to the power n would end in 5. These problems are more logical than mathematical. So please do not be scared when you see something raised to the power n. Just prime factorize and observe.